Question 4 here in our rates and equilibrium, which is Le Chatelier's principle test, talks about this equilibrium here. Consider the equilibrium system involved with the iron thiocyanate shown below. This is a common one. We do an experiment with this in class. There's also a nice YouTube clip talking about this one as well, but let's just go through it. Complete the table below showing the change for each ion solution compared with its initial thing. So when a system reaches back to equilibrium, what's the difference? And also the color change observed compared to the initial color of the solution. So we've got our changes made here, and here's our system, our species here. With these, we need to always talk about what happens initially, what does Le Chatelier say was favored, and then how does that work as a group. So our first thing is addition of iron nitrate. What is the addition of iron nitrate doing? We are adding a reactant. So we are increasing the Fe3 positive, and therefore the Ford's reaction is favored. Now, what does that mean for the concentration of iron 3 ions? So we increased this initially. It partially opposed it. However, in comparison between the initial equilibrium and the final equilibrium, it is still larger because it was only a partial opposition. Even though the Ford's reaction was favored, it's only a partial opposition to the change. What does it mean for the number of moles? Well, I increased it. We favored the Ford's reaction, but it's a partial opposition. This is going to be higher again as well. Because if you can imagine it, we've got system at equilibrium, we add more in, it spikes, and then the Ford's reaction is favored, so it starts to decrease until we reach equilibrium again, so the difference is the same. Now, what happens to this? Well, initially I added iron 3 nitrate, nothing happened to this. However, the Ford's reaction was favored, so therefore this is higher. So therefore the concentration of that will increase. Thinking about a graph again, we're sitting at our initial equilibrium. By adding iron 3 nitrate, nothing spiked, but then the Ford's reaction was favored, so therefore that slowly increased, so therefore we've got that happening. Now, what does this mean for the color? Well, I've got this as being yellow, this as being red. I've produced more red, so therefore it's become a more red color, or a redder color, if you will. It's become more red anyway. The addition of silver nitrate. Now, what does silver nitrate do? Nitrate is a spectator ion, so I can ignore that. Then I have an Ag positive. What does an Ag positive do? It's going to precipitate a negative ion. So therefore, what this is going to do is going to rip out my thiocyanate. So thiocyanate decreases. So this one's going down. What's the Le Chatelier say is going to happen? We're going to partially oppose the decrease in my thiocyanate, which is going to favor the reverse reaction. So therefore, backwards reaction is favored. And you can see here, in this type of question, I'm doing some working out over here as to what's the changes happening. Now, let's go through and compare these things to our initial equilibrium. So, thiocyanate decreased. What happened to my number of moles of my concentration of this? Initially, nothing. But then what happened to my reverse reaction was favored, so therefore this increased. So overall, we've got an increase in my iron concentration. Because what happened? Initially, nothing happened because we have no spike. We have no, by adding my silver nitrate, I'm just removing thiocyanate. So therefore, no spike initially for my iron 3 positive. I'm favoring my reverse reaction, so that's just going to slightly go down, and that's what's going to happen with that one. My number of moles follows this, so therefore my number of moles will be consistent. I didn't change it initially. All I did was change my thiocyanate, and then I favored my reverse reaction. Oops, sorry, I went down. It's going to go up because my reverse reaction increases it, so therefore that's going to go up as well. All right. Anyway, moving on to this one here. Initially, nothing happened to it. I favored my reverse reactions. This starts to go down, so therefore, in comparison, my concentration of my iron thiocyanate goes down. What does that mean? It becomes less red. You could say more yellow, technically. But if you think about it, red and yellow, red's going to take over, so therefore you're going to be talking about a reddish colour there. The addition of my water. What's going to happen with my addition of water? Addition of water is an increase in volume, so it's going to favour the side with more particles. All right, water here is the solution that it's in, so therefore you're increasing our volume, which means it's going to favour and try and, well, increase volume means decrease all concentrations, so therefore favouring the reverse reaction to produce more particles is what we're going to have happen with our water being added. So the concentration of iron. Now, by adding in water, what I've done is I've increased the volume, so sharply my concentration of this is going to start to decrease. Then what's going to happen? My backwards reaction is favoured to partially oppose the addition of water, so therefore that's going to increase, but it's never going to recover because it's a partial increase. So therefore overall my concentration of my iron 3 positive ion has decreased from when we were initially at equilibrium to when we're re-established equilibrium here. My number of moles of iron 3. Now again, I've got my initial equilibrium, which is a straight line. If I add water, I'm not changing my number of moles of iron 3 positive. I change my concentration of iron 3 positive because that goes down because of adding water decreases and dilutes that. However, it doesn't change the number of moles. The backwards reaction's favoured. So therefore, that's going to then start to increase. So therefore, my number of moles actually increases, which is interesting because how can you have a decrease in concentration but an increase in moles? You just do, because the backwards reaction is favoured, producing more of this. However, the concentration overall has dropped because we diluted our entire system. The dilution was partially opposed, but again, it's a partial opposition, so it doesn't go higher than it was before. Now, what happens to this? Well, concentration of iron thiocyanate, it's at equilibrium. If I add my water in, that's going to drop. Then what's favoured? More particles is favoured. The backwards reaction, it's going to drop again, so therefore it's going to be much lower than it was beforehand. Now, you can see the fact that in terms of colour, I've decreased my yellow. I've also decreased my red. So therefore, it's going to become less red and even a lighter yellow as well. Lighter yellow. Notice I've got less, more, and lighter or darker. These are the colour changes. I'm not just saying became red, I'm saying more red or less red in terms of my colour change and so on and so forth in that. Now let's have a look at my increase in temperature. If I increase temperature, what's going to happen is I'm going to favour my endothermic reaction. Why? Because an increase in temperature, the reaction will want to partially oppose that, and an endothermic reaction is the opposite of increasing temperature. Endothermic reactions cool stuff down, so therefore by increasing my temperature, it's going to favour the endothermic. Which direction is that here? This forward reaction is a negative, so therefore the backwards reaction must be my endothermic reaction. So therefore I've got that. Now what's going to happen to my concentration of this? I've got a system at equilibrium. Initially, increasing temperature has no effect on my concentration here, but then my backwards reaction favours an increase in my iron 3 positive, so therefore that's an overall increase in my concentration. Number of moles, again, staying consistent at my initial equilibrium, no massive change, and favouring a backwards reaction, that's going to be an increase. And then lastly, with my initial equilibrium, no massive change, favouring a backwards reaction, therefore that's going to go down, that's going to be lower. What does that mean? I have less red and more yellow colour in that. This is 9 minutes of work for only 6 marks. However, that's me explaining it and going through it really systematically and also drawing these little graphs in here. These little graphs really help in terms of your knowledge, but as you do more of these questions, chances are these little graphs will be happening in your head and you'll be visualizing this. This stuff over here I think is worthwhile still writing down. However, the graphs you can kind of just move along in your head as you're moving along with that. Sometimes you need to draw the graphs, so it's important to continue thinking about it, but it might be a lot quicker for you not doing them. Moving on anyway to part B, use the rate versus time graph to show how the addition of H2O affects the rate of both the forwards and reverse reactions. So here's my forward and reverse reactions. What's going to do that? Adding H2O is a dilution. So therefore, by definition, all the concentrations will drop. So therefore, when I first of all add H2O, my rate of my forwards reaction drops, and so does my rate of my backwards reaction. Now, when I added water, it will favor the side with more particles, all right, because it's a dilution. So therefore, that's favoring the reverse reaction. What does that mean? For the reverse reaction to be favored, it has to be higher than the forwards reaction. So therefore, when both of them drop, the forwards reaction will drop more because my overall reaction must be going backwards. And then it's going to start to go to equilibrium again because that's just the nature of the beast. All right. But you can also think about it as my backwards reaction is favored, so therefore my products are going to be used up, so it's going to start to decrease. My reactants are going to be made again, so it's going to increase until we reach equilibrium again. But the key component here is by adding water, we're diluting the system, so both reactions drop, but the forward one drops more than the reverse one because the reverse one has to be favored. There's a lot of thinking involved with some of these equilibrium questions, but this is a great one to get your head around and get your, I guess, the thinking right for it, because there's so much to do with it. And that's the last question on our practice test. I think there was only 4 questions. And then I might try and do the next practice test for you. Practice test number 2.